Well, hey folks, how you doing? Don Grant, CTC, Cutting Tool Counselor, here with another exciting episode of In the Loop TV, sponsored by Harvey Performance Company. Thanks for coming back. Thanks for joining me. Before we get started, man, are we hitting some subscribers. If you haven't already, just hit the like button, hit the subscribe button. We appreciate it. And hopefully you can spread the love and spread the word that we're helping get education of cutting tools and machining out there in the industry and doing our part. We appreciate it. So, it's been a while. What are we going to talk about? We have to talk about something that's very important and something us at Harvey Performance are very passionate about. And that is miniature cutting tools. They don't run the same, folks. They don't work the same. You don't program them the same. You don't use them the same way as a large standard end mill, cutting tool, drill, reamer. When you get miniature, things start happening. So this episode, I'm glad you came around because we're gonna call this one, Honey, I Shrunk the End Mill. See you later. Uh-oh! Oh! Well, hey folks, we're talking about miniature cutting tools, small cutting tools. I mean, we should know, we're Harvey Performance. We make some of the smallest cutting tools in the industry. Actually, end mills down to 1 thou in diameter, plus or minus a thou on the tolerance, so if nothing showed up, you got what you ordered. That could go either way. I'm kidding. But that's how small these end mills and these drills are. So when you start getting into miniature cutting tools, things are changing. The way we apply these tools are changing. The philosophy that we want to use in our application changes. That's what we want to talk about on this episode. We want to give some tips, we want to give some tricks, and we want to make sure you understand how to take that tool and use it without breaking it. So you might think, what is a miniature cutting tool? Where does it start? Well, that varies. That's in the eye of the beholder or the eye of the machinist, right? I personally look at anything that's under 1/8 of an inch, 100 thou, right around there, that's smaller, going all the way down to 1 thou in diameter as a miniature cutting tool. And this is where we need to start taking a look at this and machining it a little bit differently. Okay, folks, let's cut the right away to get started with this. When you use a miniature end mill or a miniature drill or a miniature reamer, our main objective is what? The main objective is to get that tool not to break, right? Because we're going to waste a lot of tools to get to the point of when that tool fails. If we can get the tool to sustain right out of the gate, get it not to break, we can always come up with speeds and feeds. But our main objective is to get that tool not to break. And so that's what this whole training is going to be on a little bit, is to understand why that tool breaks, why that tool fails, what are some of the things that are going to cause that thing to fail, and how do we combat that and fix that? So let's dive right into some of the things that cause these tools to break and how do we fix them and where should we start? Let's do it. So the number one problem with all cutting tools, the number one problem, and I'll say this over and over and over and over, is deflection. When a tool deflects, it vibrates, and carbide's very brittle, right? That's where we are going to break a tool. So deflection is the number one killer. So let's just talk about deflection really quick. Now, deflection doesn't mean as much on a 1/2 inch, 3/4 inch, 1 inch diameter tool. But again, we are talking about miniature cutting tools. So if we're getting down to miniature cutting tools, deflection is going to kill us. And there's something I want you to take away from this that's very important. If you just double the diameter of your cutting tool, it will result in 16 times less deflection. Think about that. Double the diameter, 16 times less deflection. So if I go from an 0.62, if I can get a 125 in there, I got 16 times less deflection on that cutting tool, okay? If I double the length of the stick out, I get 8 times more deflection. So if I stick out double the length where I'm going down just from, let's say I'm sticking out a 1/2 inch, if I stick out a 1 inch, that gives you 8 times more deflection. So what am I saying? Well, diameter is key to the deflection. That's what I was saying. So if you can go up in size, you're going to reduce that deflection. Your stick out on the bottom of the tool is also going to give you the most amount of flexion. So what do we want to do? We want to go with maximum diameter. I know we're talking about micro tools, so don't worry about it, but we want to go with maximum diameter, so be mindful of that. And we also want to go with minimal stick out. Two of the main things that we really want to focus out when we're talking about miniature cutting tools. Okay, so we understand deflection's a killer, and we're going to dive into that a little bit later on what kind of geometry and stuff. But let's talk about another thing, surface foot. Surface foot is RPM, because surface foot is always contingent on the diameter. If you're not sure how to calculate RPM, it's based on surface foot that we recommend. Surface foot is for the material you're cutting. It plasticizes the chip, anneals the chip, and makes it easy to remove. Now, when you're running a 1/2 inch diameter tool at 250 surface foot, and you times it times 3.82 divided by that diameter, you get 1 RPM. Now, as the diameter gets smaller and you still need the same surface foot for the material, guess where your RPM goes? Goes up higher and higher. It starts exceeding the maximum of your machine. Don't get worried. We can still run to the maximum RPM of your machine, but it's always good to consider some kind of high-speed spindle. Okay? Speeder head, they have coolant driven, they have air driven, they have electric driven. Those are a little bit more power on there. There's different kinds of speeder heads that can bring the RPM up so you can plasticize the chip on a miniature end mill. This is just information. RPM does help sustain tool life when you're talking about miniature end mills, especially when your surface foot starts coming up, so be mindful of that. Okay, let's talk about tool runout. Runout, right? That's where a tool in a spindle is actually wobbling and each cutting edge is taking a different chip load. All right, now I'm going to be the first guy to say that when you're running larger tools, if you have a little bit of runout, I don't want any runout, trust me, it's not good for any tool. But on a larger tool, when your chip load is larger for each tooth, if you have a little bit of runout, that's not going to cause that big of a problem. It really isn't. Cutting tools are pretty strong, especially ours. They can handle a little bit of runout. Again, I don't want any runout. But if you take any type of runout and you put that in a spindle with a miniature tool where you're starting to take tenths of a chip load or millionths of a chip load, very small, and you're exceeding the maximum runout of those chip load, that tool is just going to bounce on there. And if that tool is bouncing and that tool is deflecting, that tool is breaking. Bouncing, deflecting, breaking. That's it. That's how it's going to go on a miniature tool. So if your runout is not sustainable for what you're doing for your miniature tool, and I'm going to tell you tenths. There's grate holders out there. People make grate holders. You can get that without having to do too many fussing and fighting and stuff like that. Runout is a killer on miniature end mills. So if you are having problems and you call a guy like myself or any one of our technical personnel that work at Harvey Performance, we're going to check the runout right away, or we're going to ask you those questions because we want to eliminate that factor before we run into it. So be mindful that the runout on miniature tools is very important to get right down the middle. Take my advice on that one. Okay, so let's get into a little bit of geometry, and I like using this example when I talk about miniature tools because I've had this come up in a lot of medical shops and a lot of shops I go into, and we were able to solve some of these problems with a small end mill. Let's talk about slotting with an end mill, with a miniature end mill. When we slot traditionally with larger diameter tools, you can take a big chip load, right? You can take a high axial, you can go very deep, and we want the fewest amount of flutes as possible because the chips are big. The chips are large, we need to evacuate them. So when you're traditionally slotting with a larger diameter tool, you want very small, or low flute count. You got to evacuate the chips. That's how you do it. When you're slotting with a miniature end mill or a miniature tool, are you slotting, the term slotting, or are you making a slot? With a miniature end mill, you're more making a slot. And what I mean by that is your axial depths are very light. They're very low, sometimes even a few thousandths, 3,000ths, 4,000ths if you're at a 15 thou end mill. So therefore, chips are not a problem. And anytime we apply an end mill where chips are not a problem, we want to put as many flutes in that end mill as possible. So I'm telling you right now, if you are slotting with a miniature end mill, and let's go 0.62 or less, do not use the same principle you would use for a large diameter tool. Don't look for those 3 and 4 flutes, okay, or 2 flutes, depending on what you're doing. Look for those 5, those 6, and you can still get away with slotting with more flutes. More flutes, larger core. Larger core, less deflection. Less deflection, less breaky. That's the whole theme of this. So put as many flutes as you can in your small miniature tools, and you'll be happy you did, because you're gonna get through that material a little bit easier. Okay, so before we wrap this thing up and we get to the end, and trust me, there's a lot of thing with miniature end mills, and we'll recap a couple things and throw them in there. I want to talk about miniature drills really quick. Miniature drills. Understand something with a miniature drill. There's not a lot of chip room, okay? So do not be afraid to peck your miniature drills. And as a matter of fact, the only way you're probably going to get through some holes that are a little bit more than 4 or 5 times D, considered a deep hole with a miniature tool, is by pecking it. Take very light pecks, okay? And as you get further down in the hole, peck even more often. If you peck right out of the gate, you're going to see a lot more success than if you try to go straight through with a miniature drill. Look at the flutes. When you get that drill, take a look at it. Take a look at those flutes and think to yourself, if I was a chip in this material, would I be able to fit in that flute? The answer is probably going to be no. I know. I think about that all the time. I kind of put myself in those scenarios, but I'm a little bit off sometimes. But if you think about it and just look at how large those flutes are in miniature drills, and again, we go down to 2 thou in diameter in miniature drills, you don't have a lot of room to hold the chips. So the more you can peck that miniature drill, the more you're going to be successful, and you're not going to break your tools, and you're going to save yourself a lot of money. Yes, it'll add a little bit of cycle time, but you're running pretty fast because you can max the RPM out and your feed's going pretty good. So trust me, when you're going with a miniature drill, peck that right out of the gate, and you won't break your tools, and you'll be successful. Okay, so normally I use this part of the section to just say recap time, but we're not going to recap. We're just going to talk about a few things with miniature drills really quick, and then we're going to close this thing up. First of all, if you're using a miniature drill, the first thing you need to be mindful for is the minute you take that out of there, don't touch it, don't kick it, don't break it, don't touch it on anything. I've seen so many of these miniature tools get destroyed from the handling alone. Make sure your operators are well trained. Make sure they leave the cap on until they put it in the machine. Make sure when you're touching off on it, you don't hit the drill, the end mill, or anything like that, because it will break before you even get a chance to put it in the spindle. That's number one. Number two, touch off. If you can do non-contact touch off, where you actually check it in a shadow graph, or you check it in a Zoller and you measure that tool sticking out of your spindle, or maybe you use a laser, a Bloom laser system or something like that. Be very mindful that when you touch that off on a Renishaw or you actually hit the steel, it could break too as well. You don't want to do that. You want to be very mindful on how you're using these tools not to break them. Geometry on these. Don't be afraid to go variable. We have variable helix, variable pitch end mills. You're running these things very fast. Sometimes the symmetrical end mills will create a harmonic. Variable pitch is where we offset those flutes. We can do it on very small tools, very small tools. Can't do it on a drill. Drill has 2 flutes. How are you going to offset them? 180 degrees apart. I'm talking about end mills. Get 3 or 4 flutes on an end mill. We make them variable pitch. It changes their harmonics, and they work very well. Last thing, don't forget to put a corner radius on your cutting tools. Square corner is going to break down really quick. We want to make sure, even on the micro tools, we put a little corner radius on there, makes it a little bit stronger. We have corner radiuses down to 5 thou on some of those smaller diameter tools. We might go a little bit smaller. Not sure? Have to check in the catalog. I'll get back to you. But those are some of the tips and tricks that you want to use with micro tools. There's a lot of information here. Please, have any questions? We're available. Call us. Call somebody at Harvey Tool. The folks that make the miniature cutting tools, been doing it for many years. We're very good at it. We're very good at applying these tools. We can help you here so you don't break these out of the gate and you're successful. Well, hey folks, thanks for joining me on this episode of In the Loop TV. Don Grant, Cutting Tool Counselor. Thank you, thank you, thank you. If you haven't liked, subscribed, do all those fun things. But please come back, watch another episode. You're what keeps me wanting to do these episodes and train. If there's anything you want to see, please put it in the comments. I'll try to get to everything. I really will. Extremely busy. Love it. Love you. Thanks for watching. But before I go, there's 3 guarantees in life, folks. Don't forget death, taxes, and spring passes. Have a great rest of your week.